Guys, welcome back to my YouTube channel. And in this video, I'll be hacking this webcam. And by hack, I mean that I'm going to be transferring a live feed from this camera into a different system entirely through the internet by just plugging in this USB device into this computer without pressing any command, without doing anything aside from that. The camera gets streamed to a different system entirely. Now, this is a Raspberry Pi Pico. It's a microcontroller. I'm going to talk about this in later part of the video, but let's just do a demonstration of this right now. So I'm going to plug this into the system. Now take note, I have nothing else connected to this system aside from my microphone receiver right here because I'm doing a screen record of this laptop. Now I'm going to plug this into the laptop and just watch what happens after some time. Now the first thing that happens is that you will notice that the terminal is going to pop up, and then some command is going to be typed into the terminal, and then the terminal will be minimized. Now it seems like nothing has happened, but just watch after some few seconds what will happen. Just put your focus on this camera right here. Now you can tell that the camera is now active, and the camera is being is actually capturing some data right now. I'm going to put this system aside. I'm just going to place it on my table here, and I'm going to come to a different system entirely, my Windows system here, and I'm going to run a program. So if I click on run on this screen here, immediately I should see a live feed from that camera, as you can see here. Now I know I know this looks small, right, and it's also black and white, but I had to do that for a reason. As you can see, this is a live feed from now. This sometimes lag because of, as you can see, this is a live feed, and it's a bit slow right now because my network is kind of bad, but you can tell that it's actually a live feed, as you can see here. I don't know if you guys can see this. Yeah, so I typed nothing manually. All I did was just to plug this USB device into my laptop here, and right now I am streaming the camera into a different system entirely. This laptop could be anywhere in the world. It could be in Jamaica, it could be in America, and I get a live stream here in Nigeria on a different system. Now the only downside to this whole hacking process is the fact that the camera indicator turns on here right now. If this is a system that does not have that particular feature, there's some system that doesn't have this LED feature for the camera, right? And then that would be a perfect hacking. Alright guys, so there's some few things you'll be needing for this project. First of all, you'll be needing a Raspberry Pi Pico microcontroller. I'm going to get back to this shortly. Secondly, you'll be needing a DigitalOcean account for this project also. I'm also going to explain why you're going to need that shortly. And thirdly, you need some basic Python skill. And then fourthly, if you're like me, you're also going to be needing coffee. Man, that's great. All right, so without further ado, let's get started. I have the code to this project in the description. So there's a link that goes to the repo where you can find everything used in terms of code in this project. Now, if you get to that repo, there are some few files and folder here. So I'm going to open this flow diagram to explain exactly what we're trying to do here. All right, so I have a very simple diagram here that explains the concept behind this whole hacking process, right? It's quite simple, it's quite straightforward. It involves some few things. So what you can see here is we have two systems, right? So this is called the client. Basically, the client is the system we are trying to hack, and we have the master, which is basically the laptop that gives us the view of the client's camera. Now, at the middle of both computers, we have a server, which is basically a computer also, except that the fact that this computer is on the cloud. So you can actually use any cloud provider for this. You can use AWS server. You can use DigitalOcean. However, for this project, I'm using DigitalOcean. And if you're lucky, because at the time of making this video, DigitalOcean is currently giving new members 100 USD, which gives them the opportunity to test out their services without having to pay for it. So yeah, I'm currently using that offer right now. So if you're lucky, that offer is still valid up to the point when you're watching this video. All right, so like I said, this could be any cloud server. It could be one from AWS, it could be one from DigitalOcean, it could be one from Linode, it could be one from Lambda, whatever, as long as it's a server with a constant IP address, because that is the main reason why we're actually using this server. We need a computer that has a constant IP address, a static IP address that doesn't change, because if it changes, then it's not going to be used for our project. All right, so yeah, so we need a server, and in this server we are going to install MQTT broker in this server. Now MQTT broker is basically a communication protocol or a messaging platform that allows computer and other devices to communicate with each other. And for the broker to work, it needs to be installed on a system. Now, as long as the IP address of this system here or this server doesn't change, it means that we will always have access to this MQTT broker to publish and subscribe to publish and subscribe messages to it. Now, if you don't have if you don't know what MQTT broker is or what MQTT is all about, I have links in the description that takes you to videos that explain more about that, right? But basically, like I said, it's basically a messaging medium for computers and devices to communicate. So the way it works is that you have a device or a computer publishing a message to the broker, right? And you have another computer or device taking that message has been published by the other device and then using that message for whatever it needs to use it for, right? So yeah, so we're going to be installing the MQTT broker in our server. Now, I'm using DigitalOcean for my server. You can use anything like I said earlier. And there are a few ways to go about that. You can do this via your dashboard. So if you register for DigitalOcean, you don't have a dashboard like this. You might not see anything here under your resources, right? Because you don't have any resources created. But I have some few resources here, right? But basically, you want to click on the create button, and then you want to click on create cloud servers. And you click on that, then you will have to set some specific information, select what kind of operating system you want to use for the server. You can use the default Ubuntu, and you can change this to a cheaper. You don't really need something so powerful, right? So you can change this to a cheaper subscription. You can use this or this, right? I think I'm using the $14 per month, right? And everything else is fine. You can leave everything else as default, and you can change the name. So you can change this. So I'm going to call this MQTT. And what else? Seems I have to do some other things, right? Okay, so at this point, you can decide to use a password. You can decide to create a password for the machine, for the server. However, I'm not going to be using the password option. I advise I use the password option, right? So you don't have to go to the stress of creating SSH keys, right? But because I already have SSH keys set up for mine, I'm just going to use that. So yeah, then you can click on create droplets. All right, so it's going to take some few seconds for the droplets to be created. So let's just wait for that. So while I'm waiting for this, I'm going to go back to the diagram here. So what we're actually doing is we have a Python program running on the client's computer. that basically activates the camera and then send frames or images from the camera to the server. And then we have the master computer, which is your own computer, that goes into the broker and pick those images of frames and then display it on the master, right? So we have two Python programs. One is the client, one is the master program. Then we have the server running the MQTT broker. So the server is basically the medium of communication, right? Now, the tricky part about this whole architecture is the fact that, of course, you can't just you can't just give your friend a Python program and expect your friend to just run the Python program without asking you what the program does to the system, right? And that's where the interesting part comes in, right? So we are going to do it in such a way that whenever the Pico device is plugged into the client's computer, the Python program is downloaded from a source, basically a GitHub account or a GitHub repository, which is the same repository here. And automatically that script is executed even without the owner of the laptop knowing, right? It does it very, very fast. It happens in very few seconds, right? So we'll get to that shortly. I'm sure you how that works. But for now, let's just create this connection and then let's see this in action. Then we'll talk about the aspect of running the script automatically. So going back to the DataOcean here, I can see that, yeah. So now I have an IP address attached to that broker. So you can, sorry, to that server rather. So you can open this and just go straight to access. I think it's still loading. Yeah, so it's still taking some time to boot up. All right, so you can either go to access or you click on the console here. So I'm going to click on console. This is going to open an SSH window for me. So basically connected to the system right now. Now the first thing you want to do is to install the MQTT broker to the machine. So you do that by simply saying, okay, I have the command here. So if you go back to the repo, under server, under main.tf, so these are the commands you need to copy. So I'm going to start with this. This says command to install mosquito. So we come back here, we can paste this here. This is going to install mosquito. So mosquito is basically an MQTT broker. There are other options, but mosquito is one of the most popular one used, and it's actually very, very smooth to use. All right, so we have that installed already. The next thing you want to do is to configure the mosquito so it can be accessed from other computers via the internet, right? So I also have the code for that here. So there are just few lines of code here. We need to run this, copy this, and paste this here, and copy the next line here. You can also copy this, paste this here, and then finally we have the last command here, and you paste that here also, and enter. Now in case you are curious on what is I'm actually doing at this moment, is what I'm doing is actually quite straightforward. So first of all, whenever you install mosquito is executed as a service on the machine. A service is basically something that comes up automatically, right, when you turn on the system. So what I'm doing at this point is I'm actually creating a config file, as you can see here. So I have this config file located at this location here. So I'm using the touch command to create that, and in that config file, I am writing two lines of configuration into it. The first line is to open the port 30,100. This is going to be the port in which the broker is going to be launched and accessed from external computers, right? And I'm also allowing anonymous, right? So basically, I'm making it a passwordless broker. So you need not to enter any password in order for you to access the broker, right? And then after that, I'm restarting the Mosquito service. So right now we have this server exposed to the internet on this port 3100. Right, so how do we confirm this? So what we need to do, you can actually minimize this right now. In fact, as a matter of fact, we're actually done with this. We can cancel this. We have no reason to come back here. All right, so when you have the broker installed and then configured, the next thing you want to do is to confirm that everything works fine. So there are a few ways to actually confirm that. You go back to your dashboard here, and what you want to do is to copy the IP address of the server you just created, which is going to appear on your dashboard here. So you want to use this IP address here. So I'm just going to copy this, and I'm going to open a software called MQTT Explorer. So basically, this software allows you to manage your broker, your MQTT broker. So what you want to do is to change this to that IP address you just copied, change this port to the port 3100, because that was what we used in configuring the broker, right? Then you can give this any name. You can just call this bad camera. Now if you are able to connect to this successfully, it means that everything is working fine. Okay, fine. So I was able to communicate with this. All right, so now we have our broker working program. So going back to the flow diagram here, we have this in place. The next thing we want to work on is the Python program that's going to be executed on the client's computer that publishes images from the camera to the broker. So I'm going to open my Visual Studio Code here and then explain that part of the code to you guys. All right, so under the client's directory, let me expand this. So under the client's directory here, I have the main.py, and then this is the code here. So the first thing you want to ensure is that you have all the libraries installed. So we need two libraries. We need OpenCV and we need Paro MQTT library. I have a requirement.txt here, so you can just go ahead and install these requirements by simply typing in pip install requirements, -r requirements.txt. So if I run this command, it's going to install both Paro and OpenCV. Now I already have this installed, so I'm not going to run this command, obviously. I'm just going to activate the environment. I have that libraries installed. The code is quite straightforward. I have some basic imports here. I'm importing OpenCV as CV2. I'm importing the Paro MQTT.client class as MQTT. I'm importing base64 and I'm importing sockets. Now I'm going to show you the reason why we have all this imported. Now I'm using the sockets here to get the host name of the computer. So the host name is the name of the computer where the program is running. So in this case, my host name is going to be Amazing because that is the name of my computer, right? It could be anything. So when you're installing the OS of your computer, be it Linux or be it Windows, you're usually asked to create a name for the computer. So that's what your host name is. So here I'm using the sockets module to get the host name, and I'm also getting the IP address of the hosts. Then here you want to replace this string with the IP address of the server you just created on DigitalOcean. So if you go back to DigitalOcean, you can actually copy that server IP address you just created here and come back here and just replace it here. All right, so this way the client's computer knows where the broker is running and where it should send data from its webcam to. Now I'm creating a topic here. So a topic basically is like it's like a folder on the broker where you want to publish images or send data to. So the topic here is basically made up from the host name the um, of the computer. So let's remove this. This is a mistake, right? So what I'm trying to do here is, let's say the host name is something like amazing. So this will be amazing underscore camera, right? So I'm using the dot format here to format the string. All right. Um, so now I have a while true loop, and the while true loop, I have a very simple algorithm here. First of all, I'm creating a video capture class, which is basically class that's going to be used to capture images from the webcam. I'm also creating a client instance from the client's class in the MQTT we just imported here. And I'm connecting that client to the broker, which is the IP address of the server we created on DigitalOcean. And also indicating the port in which the broker is running. And I have a try and accept command here. Basically, this is just to catch errors. If anything happens while these following codes are being executed, if anything happens that leads to an error, then because I have this covered in the try and accept command, it's going to just repeat the entire process over again and keep trying until it connects to the broker again. All right, so this is just a basic OpenCV function. So what I'm doing here is I'm checking if the camera is actually opened at the moment, and if it is opened, I am reading the current frame from the camera. So the way cameras work is cameras actually capture images. It's called frame, right? At a particular number of at a particular frequency, right? So the camera keeps capturing frames, let's say like 20 frames per second, right? So I'm taking that frame, each frame that is being captured by the camera, and I'm doing two things with those frame, right? First of all, I'm going to resize the frame to a very, very, very small size, which is 150 by 150, right? Now, the reason why I'm doing this is because this image is going to be transferred via the internet, right? And we want to keep the payload as light as possible, right? Probably a few kilobytes, because if it's a very large image, then it means that it's going to take time for it to be sent to the master device, right? The master laptop. So we want to keep it as smooth as possible and also make sure it's happening in real time. So we have to resize the image to a very small size. So I decided to go with 150 by 150, right? Now after resizing it, I'm also doing one more thing. I am converting the image to a black and white image. And the reason I'm also doing this is also to reduce the size of the image. So I believe after doing these two steps, then the image should reduce to probably some few kilobytes, right? And because of that, it's faster to be it's transmitted faster rather to the receiving device. The next thing I'm doing here is to encode the image. Now I have to do this to make it to make it sendable, if there's a word like that, to make it sendable via the MQTT broker. So we need to convert or encode the image to base 64. This way it is also helping to reduce the size, and it is also helping um, to ensure that everything is sent properly. So we encode and convert that to base 64, and after doing that, we send that message by using the .publish method coming from the client class. And that's all we are doing. So at the end of if anything happens at the end of the except here, we just have to release the camera and then disconnect the client from the broker. And that's all. This is just 33 lines of code, right? Now I'm going to run this code so you guys can see what is going to happen. So now take notes. Going back to the Explorer here, you have no messages currently being published to the Explorer here. So let me see if I can increase the font of this so you guys can see this clearly. How do I increase the font of this? I'm trying to remember this. Okay, yeah. So Control Shift equal to All right. Okay, so at the moment we don't have any message being published to the Explorer here. All we have is just the default messages in the system directory here, right? So I'm going to minimize this and let's have this here. So if I run this program, which is the client's program, my camera should actually start capturing. Okay, so as you can see, it says connected and publishing frame. And now you can see that I have this. It says Daniel Ogunlolu underscore camera, right? So this is the image being published to the MQTT broker, as you can see here. So the name of my computer is actually Daniel Ogunlolu. So that name is coming from here, as you can see here. So I made a mistake. I said amazing initially, but actually Daniel Ogunlolu. And this name is going to be different for different computers, right? So if you run this program in a different computer entirely, then the name that appears there is going to be different. So probably if you're running this program on your friend's computer, it's probably going to be your friend's name underscore camera. But the main point here is the fact that the camera image is being published to the broker now. Now we have this image being published to the broker, right? Now the next thing we want to do is to create another program that allows us to view this image. Now this program is what is going to be executed in the receiving computer. So if you go to the master program here, we also have the main.py here. All right, so this is the master program. This is going to be your own system where you want to view the camera that is actually being hacked, right? So I'm importing some few modules here. I'm importing base64, OpenCV, NumPy, the PAL, and then JSON, right? I have a class that I've created here. Now, you don't necessarily need to create a class to do this, but I decided to do it this way for some reason, because the truth is that I actually extracted this part of the code from an old project of mine, right? But basically, in this class, all I am doing is just to connect to an MQTT broker, as you can see here. So the class initializer is taking 3 arguments: the broker IP address, the broker ports, and then the topic in which you want to receive the images from. In our situation here, the topic is this name here. So you can just copy that, Ctrl C, and that will be the topic we're going to receive the image from. So what I am doing here is simply creating an instance of the MQTT client, and I'm also connecting to the broker, and I'm connecting to that port, right? And I have a method here called getFrame. Now getFrame returns the frame received from that topic, right? And then the frame received from that topic is actually gotten from this on message method here. So the way MQTT broker works is that whenever a message is received on that topic that has been declared, this on message method will be executed. So what we are doing in on message is simply decoding the image that has been received from the broker, because remember we had to decode it to base64, but now we had to encode it rather on the client side, and now we are decoding it. We're also converting that image to a NumPy array, because that is what OpenCV supports. And we are setting that NumPy array to self.frame. So whenever you call the getFrame method, that frame is actually what is returned to you. All right, so in the while true loop here, before the while true loop, we have to do two things, right? We have to input the server IP address. So I'm going to just copy that from the client's main here. Ctrl C, and I'm going to come back here and then just post that here. And then here we need to put in the topic. Like I said, we're going to get that from the Explorer here. So we need to copy this name and have that here, or you can just type it out, right? So let's see, Daniel Ogololo underscore camera. Now, the reason why I actually did it this way um, is because I want the system to support multiple cameras. So imagine if you have the same program, I mean the client's program, right, running on 10 different computers. You're going to have a different name for each of those topics here on the broker. So if you have the client's program running on a computer that is called, let's say, Linux, you're going to have Linux underscore camera. If you have the client's program running on another computer that is called, let's say, James, you don't have James underscore camera, right? So you can actually use this system to hack multiple cameras, right? So whatever camera you actually want to view, you need to copy the name of the topic in which the camera is being published to, right? And then you need to put that here. So we are passing this two information to this class initializer here, and that would go ahead to connect. We are passing the broker the ports. Remember, we are using the port 3000, and we're also passing the topic, which is this here. And so in this while true loop here, using the object we just created here, we are getting the frame from that topic, and we are displaying that on the screen using the IMShow method from OpenCV. This is just 49 lines of code. So let's execute this right now. So basically, I'm hacking my whole camera because I'm running both the clients and master program on my system. Let's see what happens. All right, so yeah, so I have to actually run this in a different terminal. So let's do this. Okay. All right, so I'm going to just cd into master, and I'm going to run python main.py. Okay, as you can see here, I just officially hacked my own camera, and now you would see that this is happening. This is actually very smooth in the sense that it is happening in real time. Now this is possible because of the way I resized and also converted the image to black and white. So if I didn't do that actually, this is going to lag a lot. I have a slow internet connection. That's one thing you need to know right now. I'm currently running on 4G, which is actually not 4G, but that's not the topic for today. But you can see that even despite my slow internet connection, this is still happening in real time. And that's because of the image itself has been downsized to some just very few kilobytes. So guys, now I have the client and master program running on my system. So it's like I'm hacking my own camera. So what we want to do, so we're going to stop this by pressing Q. Yes. And so what we want to do is to find a way to transfer this client's main.py to a different computer entirely and run that program in that computer so we can, have that person camera display on this system here. Now, that's where the whole hacking trick comes in, and that's where Raspberry Pi Pico comes in. So there is something called bad USB. So I'm going to just Google that so you guys can see what it looks like. Now, a bad USB is basically a tool that is used by hackers to gain access to your system. So a bad USB looks like a regular USB device. It looks like a regular flash drive storage device, right? However, when you plug it into your system, it does some things. It's first of all, the bad USB acts as an HID, and HID stands for human interface device. So an example of an HID rather is your mouse and your keyboard. Your mouse and your keyboard. And so when you plug in the bad USB into your USB port on your system, it acts as a keyboard and immediately begins to run some commands on your system. Sometimes you can deactivate your antivirus or get your password or copy some files on your system and upload them to a cloud storage or whatever. However, in our case, we're going to be programming the Pico, Raspberry Pi Pico to act as a bad USB. So what we're trying to do here is that whenever this device is plugged into the client's computer, what happens is that it's going to act as a keyboard, and then it's going to do some few things. I'm going to show you what it's going to do, right? I have another directory here called the Pico arc. So in this directory, I have some few files, but the one that is really important I want you guys to pay attention to is this one called payload.td. So I'm going to open that. Now, this is what is happening. Whenever this device is plugged into a computer device, these are the commands that are being executed, right? So the first thing that happens is the device runs Control Alt plus T, Control plus Alt plus T. Now one thing you need to notice is that this would only work for a Linux computer. So the person you're trying to hack would have to have a Linux operating system running on their system. Now you can actually edit this payload.dd to work for Windows also, but I only have the one for Linux at the moment, right? So whenever you press Control Alt T on a Linux device, what happens is that the terminal comes up. So I'm going to try that, right? You can see what happened, right? So Control Alt T is basically the shortcut to open a terminal on Linux, right? So that's the first thing that is being typed by the Pico device whenever it plugs into a system. And the next thing you can see, there's a delay that says 10,000. So it's just going to wait for 10 seconds, right? Just to ensure that the terminal is actually up and running. And the next thing I'm doing is to enter a command that says cd or cd then this characters here. So if you do cd this character here, basically what I'm doing is to go to this directory. So this is the home directory. So I'm cding into the home directory. Right now in the home directory, I am running this command that says git clone this, right? So if you copy this and then you run this on your terminal, it's basically going to clone this whole GitHub repository we have for this project, right? So if I run this now, because I already have that, so what I want to do is I already have that running on my system actually. So let me see if I can remove that. I already have that directory on my system, so let me see if I can remove that. Yeah, so I'm going to run this command again. So you can see this is going to clone the whole repository, and then after that I'm going to wait for 1 second, and then I'm going to cd into bad camera arc, which is the repository we just cloned. So I'm going to cd into bad camera arc, and now I'm inside that directory, right? Now the next thing I want to do is to install the requirement.txt. So just to be on the safe side, I want to ensure that the clients we are trying to hack as the requirement, which is OpenCV and then PAO. So I'm going to just do pip install. Now the clients, the requirements.txt, okay, pip install minus r requirements. Now this is going to install all the libraries listed in the requirement.txt in the repo. Like I said, I already have that also installed on my system already. Now after doing that, it's going to wait for another 1 second, and then it's going to run the main.py inside the client directory. So basically there's just a command that says python client main.py. So if I execute this, it's going to run the client. So I'm going to just stop there for now. But basically you can get you understand the concept here, right? These are just instructions or commands that will be executed whenever you plug in the Pico device into any computer, any Linux computer, right? Now the question is, how do you actually get this to work? So so a few things we need to do. First of all, we need to download CircuitPython for Raspberry Pi Pico. So CircuitPython is it's just it's similar to MicroPython, which is like Python for microcontrollers. We're going to need to download that file, which allows us to program the Pico to act as an HID. which is an human interface device. So in the description I have the link to this page, so just click on download this UF2 now. So download that. Now the next thing you want to do is to plug in your Pico device into your system via USB. Now one thing you need to do is while you are before you plug in the Pico, you have to hold down this white button here, this boot button here. Hold it down and then plug in the Pico. All right. So now, when you plug in the Pico, it's going to appear as a USB device on your system, as you can see here. So I have a device called RPI-RPI2. So what you're going to do now is you're going to open your downloads in a different window entirely, and then you're going to drag that UF2 file you just downloaded into this Raspberry Pi Pico. Now the moment you do that, it's going to take some seconds, and then the device is going to reset and reconnect to your system. Now if everything is successful, it's going to reconnect to your system, and this time around the name is going to be CircuitPi, and this means that everything has been copied properly. And there's one more thing you need to do. Now you're going to go back to the repository, and everything on the Pico arc, the library, the system volume, everything here, you know, copy it into the Raspberry Pi. Now this is the point where you can edit this if you want to. So if you want to make this work for Windows, you have to figure out a way to run these same commands on Windows, right? Or to run whatever command that's going to do the same thing that this guy is doing on Windows, right? I'm probably going to do that and then update the repo later. But this same concept is going to work for Windows, right? As long as you can get the appropriate command to download this code and to install the requirements and to run the Python script. So yeah, so at this point you can edit this if you want to. If you want to add some extra commands there, you can go ahead and do that. But our aim here is just to install the requirement.txt and then also start the main.py on the client's device. So you're going to copy all this in the Pico arc. So the way you can do that is to you can open this guy. You can just go to the repo here, and then you have the Pico arc. Just copy everything here. So just copy this and then just paste inside this CircuitPi here, and that's all. Your USB Pico device just become a bad USB, and that can be used to hack anybody's system. So while you've copied all this successfully and you've done copying that, you can cancel all this and then unplug the Pico device. If you want more information about how this works, I mean the codes for the Pico arc, I'm going to leave a link in the description. But basically this is called a Docker script. A Docker script, right? Everything else should remain unchanged, right? If you want to change the commands, just edit the payload.dd, and here you go. You have your bad USB that basically runs this command anytime it is inserted into a Linux device. Alright guys, so that's the end of today's video. So before I round up, I want to say something. This project was created entirely for learning purpose, right? So please do not actually go ahead to hack people's camera. It is not ethical. It's not something that you should be doing, right? However, I feel like knowledge in this project can be applied to other places, right? For instance, you can actually use this as a security kind of thing. So for instance, you can have the client program for the running on a Raspberry Pi with the camera attached to it, and have that in your house. And then whenever you go traveling or go somewhere else, you can just pick up your laptop and then run the master program, and then you have access to the camera in your house, you know, in real time, so you can actually monitor your house. Now, secondly, this is also to tell you that you shouldn't trust any USB device. Do not plug any USB device, especially one that you don't trust or you don't know the source, into your system. People can even do worse things than hacking your camera. They could delete all your important files. They could transfer all your files into a different system entirely. So it is important that you only plug in any USB device that you know the source and you trust the source, right? So yeah, so thank you very much. Please subscribe, like, and most importantly, please share this video. I'll see you guys later. Thank you very much. Peace out.